Mars, the red planet. Our planetary neighbour, unlike us, has no tectonic plates, however faulting can still occur due to stress built up in the planet's crust as it shrinks and cools. This has proved invaluable in furthering our knowledge of this dusty planet. In 2018, the lander from NASA's InSight mission arrived upon the surface of Mars and began the land-based phase of its operation. Amongst the equipment it had been fitted with was a seismometer so that it could measure seismic signals that were incident upon it. These signals can indeed come from marsquakes, but may also come from wind or other sources, so scientists back here on Earth look for the distinctively shaped wiggles that indicate that they are looking at a marsquake. These signals propagate into the interior of the planet and are reflected back when they meet a new surface. The echoes that are received can then be used to model the interior of Mars by using the time between the signals to approximate the distance that the wave has travelled. So what does the interior of Mars look like? There are two major models for the crust, either as two sublayers, in which case the crust is likely to be 12 miles thick, or has three sublayers and the crust is likely to be 23 miles thick. The mantle is likely 969 miles thick, and the core is likely 1,137 miles thick, which means that it makes up approximately half of the radius of the planet. Interestingly, it was also found that the core is molten, as there have been shadow zones where S waves, which can't travel through liquid, are not found on the surface of the planet. This is similar, but quite different to Earth, which has a much thicker mantle in comparison to its core. These models were put together using 35 marsquakes, and so the question is, will more data and potentially crucially bigger earthquakes give us a better understanding of Mars in years to come?